Hi, I'm Perry Kleinhens. I'm a recent graduate from MIT, and today I'm going to be talking to you about the zipline. Now, you've probably already seen two limiting models of the zipline already in the class, and so I'm just going to go over them pretty quickly. In the first case, we assume that all of the mass is in the rider and that the string is totally massless. When that happens, the mass of the rider will pull the string down until it forms two straight lines and it'll follow the path of the ellipse, like this. In the other case, we assume that the rider is totally massless and that all the mass is in the string. In that case, the path the rider follows will be that of the catenary, or the path that this hanging string forms. Now, obviously, the rider isn't totally massless, and neither is the string, and so the path that the rider will follow will be somewhere in between these two. In order to understand that, we're going to need to understand the forces acting on the rider, and to do that, we're going to draw a free body diagram. So our rider has mass m, and so there are four forces acting on it. There's the force of gravity, there's the tension from the right, the tension from the left, and the drag force. So now that we have our free body diagram, there are two things that we need to unpack. First, the forces on the rider do not balance. And in fact, this is a good thing. We're going to use the net force on the rider at a certain time step to figure out the position of the rider at the next one. So if the force is balanced, the rider actually wouldn't be accelerating at all. The second thing to consider is that I haven't really told you what this drag force is. And that's because we're sort of lumping a lot of things together there. There's the friction of the pulley against the wire. There's air resistance. And all of these things are pretty complicated, actually. And it can be tough to model them.